Hey folks, welcome to my channel, Number Pen. Today we have an interesting problem to solve under the topic Applications of Differential Calculus. So here you have the problem on the screen. A conical water tank with vertex down of 12 meters height has a radius of 5 meters at the top. If water flows into the tank at a rate of 10 cubic meters per minute, how fast is the depth of the water increasing when the water is 8 meters deep, right? So let's take a minute to understand the problem. Let's probably use the pencil tool to draw this. So here we have a cone, and this is the tank, right? Apologies for the diagram, guys. And this you've got R, which is 5 meters, and you've got the height, which is 12 meters, right? And you've got water filling into this tank out here, which is again filling into this conically shaped tank, and the depth of the water is increasing, right, with respect to time. And we have been asked to find what is the height, what is the rate of change of depth with respect to time when we reach 8 meters height for the water within the tank, right? So we have the diagram with us. So we have a similar triangle here. So the triangle formed by, let me use a highlighter. The triangle formed by the water, which is what I marked by green, and the triangle formed by the tank, which is, let's say, this, right? Now these both are similar triangles, right? Because you've got a cone and the cone is a regular cone, right? So that's why we make this assumption. So when we have a similar triangle with us, when I say triangle, I'm referring to the triangle formed by, let me indicate vertices so that it becomes a lot more clearer. Let's say this is A and this is B, this is C, this is D, and this is E, right? So enough of drawings. Let's go back to the writing board. So we have a cone. We have the volume of the cone is 1 by 3 into pi into r square h, right? We have been given dv by dt, which is 10 cubic meters per minute, and we have been asked to find dh by dt. Sorry about this. Dh by dt. So we have the volume of the cone. We know that the volume of the cone changes. When I say volume of the cone, I'm referring to the volume of the water inside the cone, right? Volume of the water inside the cone. We know that it changes with respect to time. Here we have the concept of similar triangles where triangle triangle ABC is similar to triangle DEC, right? So we have DE by AB equals DC by AC, right? And so DE is what? Let's call this as X, right? And we have AB is the radius, which is 5, and you've got DC, which is the height, which is Y, and AC, which is the total height of the tank, which is 12. So we have X equals 5 by 12 Y, right? So I hope you guys are with me here. Let's go back to this equation. So we have the volume of the tank is 1 by 3 pi r square h. So what is the volume of the water inside the tank? Volume of the water inside the tank is x square into y into 1 by 3 into pi, right? Now what is x and y? X and y is nothing but this is x, dE is x, and dC, which is the depth of the water inside the tank, is y, right? So let me call this here. dC is the depth of the water, y, and dE is radius formed by, how do we call this, conical, let's call this water cone. Okay, for the sake of understanding, let's call this water cone. So we know that 1 by 3 into pi into x square is 25 by 144 times y square, right? So that becomes y cubed then. So for the sake of avoiding confusion with too many numbers on the screen, I'm going to call c equals this, right? And let's come back to this later. Right, so dv by dt equals c into what is dy by dt of d by dt of y cube is 3y square into y, excuse me, right? So you've got dy by dt is equal to 10, and then you've got c, let it remain at c for the moment, into y square. So we've been asked to find when y equals 8. Sorry, here you have dy by dt, right? When y equals 8, which is 8 square, which is 64, dy by dt, right? So we have dy by dt equals 10 divided by square is 64, and you've got 64 into 3, which is 192. So you've got dy by dt equals 10 divided by 192 into c, right? So c is in the denominator. Now we'll go back to c. 10 divided by 192 into pi into 25 by 144, right? So 3 goes to the numerator. So we have 30 here, right? And you've got 144 also going to the numerator. So it becomes 144 into 30 divided by 192 into 25 into pi, right? So let's do that quickly with the calculator, which is zero point 0.9. So zero point 0.9 divided by pi is the right answer. The answer. You folks will have to tell me whether I'm right here or not. Final rate of change of the water depth, right? Thank you, folks. I hope you did learn as a part of this problem solving. Stay tuned to my channel for more interesting problems in mathematics. Thank you and have a good day.